Hi everyone, this is Srikanth as Assistant Professor of EEE Department. In this session, I am going to give you the basic definitions on electrical circuits. The name itself consists of circuit. What is an electrical circuit? The circuit is nothing but it is a interconnection of two or more electrical elements, and where the current is going to flow. That is, there should be a closed path. An electrical circuit is a interconnection of two or more electrical elements with a closed loop is called an electrical circuit. Here, let us take the example: a voltage source, resistor, inductor, and the capacitor. That is Vs, R1, R2, inductor, and capacitor. This is going to form a loop which is going to provide us the current. That is called a circuit. The second one is, what are the properties of electrical circuits? The basic properties of electrical circuits are: there should be a closed path. First point is there should be a closed path, then only a current can flow. And a circuit must have at least one energy source, because the circuit without energy source, no current will flow. So there is no function is going to take place within the circuit. So in order to get some function which is required, we need to have one energy source in the circuit. An unregulated and controlled type of power, as well as resistors, capacitors, and inductors, are among the electric elements. So along with this energy source, we also contain resistors, capacitors, inductors in the circuit in order to get our required output. So these are the major properties of electrical circuits. State and explain Ohm's law. Ohm's law states that at constant temperature, the voltage across any conductive material is proportional to the current flowing through it. So V is proportional to I, which is equals to V is equals to IR, where R is the proportionality constants and it is called a resistance. And where resistance is defined as it is the property of a material which opposes the flow of electrons. That is called a resistance. So the major points which we need to remember in the Ohm's law is: one is at constant temperature, and the second one is there should be a conductive material. The material whatever we are choosing, that should be a conductive material or conductor, we can also call it as. So This is corresponding to the Ohm's law. The next is what are the limitations of Ohm's law. So first limitation is Ohm's law cannot be applied to unilateral networks. This is Ohm's law is applicable only for conductive material, not for insulators, not for semiconductors. Okay. So Ohm's law cannot be applied to unilateral networks, and unilateral networks allow the current to flow only in one direction. Examples of such networks includes diodes, transistors, etc. If we are having semiconductor devices, then the Ohm's law is not applicable. And Ohm's law is second one is Ohm's law is not applicable in the case of nonlinear objects. Example of nonlinear components include thyristor, and this thyristor is also another type of semiconductor element, where in this we are going to get the nonlinear characteristics. So this is not applicable for nonlinear elements. And Ohm's law will not work in the case of non-metallic conductors. If we are not having non-metallic conductors, then Ohm's law is not applicable. The next one is define KCL. KCL is nothing but Kirchhoff's current law. Kirchhoff's current law or KCL states that a current entering into a junction is equals to currents leaving from the junction, or sum of currents entering into the junction is equals to sum of currents leaving from the junction. Or we can also write this one as the algebraic sum of currents at a junction or a node is equals to 0. That is, here if we take some currents which are the part of the circuit, this is the junction which we are going to take. This is, let us consider I1, I2, I3, I4, I5. So I1 plus I2 is equals to I3 plus I4 plus I5. Here I1, I2 are the current entering currents from to the junction, and I4, I3, I4 and I5 are the currents leaving from the junction. That's why I1 plus I2 is equals to I3 plus I4 plus I5. Or we can also write this equation as algebraic sum of currents is equals to 0. That is I1 plus I2. That is currents, entering currents is considering it as positive, and leaving currents is considering as negative. I1 plus I2 minus I3 minus I4 minus I5 is equals to 0. This is the equation corresponding to the KCL. The next one is define Kirchhoff's voltage law. The Kirchhoff's voltage law states that in any closed loop network being driven by a voltage source, the total voltage around the loop is equals to the sum of all the voltage drops in the loop, which is equals to 0. And in other words, we can also call it as algebraic sum of all voltages and voltage drops within a closed loop must be equal to 0. Here, KVL is nothing but whatever the sources, sum of voltage sources is equals to sum of voltage drops in the circuit, or in a closed path. Or we can also call it as algebraic sum of voltage in a closed path is equals to 0. If let us consider a voltage source with two resistors in series, Vs, R1, R2. This resistor voltages will be considered as in this particular direction VR2, and this is the current direction which we are going to give. So if we apply the KVL, if current enters the negative, that will be written as minus Vs, plus current is entering the positive, so plus VR1 plus VR2 is equals to 0. That is Vs is equals to VR1 plus VR2. This is Kirchhoff's voltage law. The next one is, what is equivalent resistance? Equivalent resistance is nothing but whenever we are having some number of resistors connected together, that number of resistors can be replaced with a single resistance by considering the properties of series and parallel resistances. That single resistance is called a equivalent resistances. If a single resistance can replace a combination of resistances in such a manner that the current in the circuit remains unchanged, current and voltage are unchanged, then that single resistance is called equivalent resistance. The next one is, what is the difference between loop and mesh? Here, the difference between loop and mesh is nothing but both are the closed paths, but in loop we are going to have, there will be some inner loops, whereas mesh there is no other inner loops are present. That is, loop is a closed path in a circuit which none of the nodes repeats more than once, while a mesh is a closed path in a circuit in which no other closed paths are present. Here there may be another closed paths will be present in the loop, whereas for when we go with mesh there is no other closed paths. Now, what are the limitations for mesh analysis? For mesh analysis we have to apply the KVL. So in order to apply KVL, the circuit must be planar, and as the number of meshes increases, the number of equations will increase, which makes it inconvenient for solving. That is, when we go with 3 or 4 meshes, then it is easy, but when we go with more than 4 meshes, then the solving of the equations will become difficult. These are the two limitations. The first one is, mesh analysis is useful only when the circuit is planar. As the number of meshes increases, the number of equations will increase, which makes it convenient for solving. Inconvenient for solving. What is the difference between mesh analysis and nodal analysis? So, the mesh and nodal analysis are the applications of, mesh analysis is the application of Kirchhoff's voltage law, and nodal analysis is the application of Kirchhoff's current law. Mesh analysis is used to calculate the currents in the meshes, whereas nodal analysis is used to calculate voltages across the nodes. This is the major difference between the mesh and nodal analysis. The difference between mesh and nodal analysis is that nodal analysis is an application of Kirchhoff's current law, which is used for calculating the voltages at each node in an equation. While mesh analysis is an application of Kirchhoff's voltage law, which is used for calculating the current. Next, what is a dependent source? A dependent source in an electrical network is defined as either a voltage source or a current source whose value is dependent on the voltage or current in the network. Dependent source is nothing but the name itself says that the source magnitude or source value is depends on some other parameter in the circuit. Either it may be voltage or current. In this, we are having different types of sources. One is voltage controlled voltage source. That is nothing but if the voltage source is controlling the value with a voltage in the circuit, then that is called voltage controlled voltage source. If a voltage controlled, that is voltage of any other parameter in the circuit is controlling the current source, then that is called a voltage controlled current source. And next one is current controlled current source. That is nothing but current in any part of the circuit is controlling the magnitude of the current source. And current controlled voltage source, that is current in any part of the circuit is controlling the voltage source. Then that type of voltage source is called current controlled voltage source. And these dependent sources are represented with a diamond shape. Here plus minus, this plus minus indicates that voltage source. In this, if we take k times the Vx, that is nothing but voltage controlled dependent source. If it is k times the Ix, that is current controlled voltage source. And in the same way, we can also have the dependent current source. K times the Vx, k times the Ix. Voltage controlled current source and current controlled current source. These are the four different dependent sources. What is root mean square value? Next one. The root mean square value is also known as effective or virtual value of an alternating current, and it is the value of DC current when flowing through a circuit or resistor for specific time period and produces the same amount of heat which is produced by the alternating current when flowing through the same circuit or resistor for a specified time. Here root mean square value is nothing but for an alternating voltage or for an alternating waveform, we cannot give a particular value. So that value will be calculated which is corresponding to the DC, that is nothing but the root mean square value. That value will be calculated and that value is going to be constant throughout the voltage is available. Okay, so RMS value is equals to 1 by time period integration 0 to t Vm square sine square omega t and d omega t whole power 1 by 2. This is the equation to calculate the RMS value. For RMS value of f sine wave is Vm by root 2. The next one is define form factor. Form factor is defined as the ratio of RMS value to the average value of an alternating quantity. Form factor is equals to RMS value, ratio of RMS value to the average value. So here form factor is nothing but the ratio of RMS value to the average value. The next one is define peak factor. It is nothing but crest factor. It is also called as crest factor or peak factor. This crest factor or peak factor, which is defined as crest factor or peak factor, is defined as the ratio of maximum value to the RMS value of an alternating quantity. That is, peak factor is equals to maximum value or peak value divided by RMS value. The next one is define charge and electric current. Charge is a electrical property. Charge is an electrical property of atomic particles of which matter consists measured in coulombs. Charge is nothing but whatever the atomic particles in the materials, that is electrons, protons, neutrons. All these atomic particles are going to have some matter that is nothing but a charge that is measured in the coulombs. And electric current is nothing but electric current is the rate of change of charge carriers. Rate of change of charge carriers, where I is equals to dq by dt, and it is measured in amperes. A DC current that remains constant with time, whereas alternating current that varies sinusoidally with time. If it is a DC current, that value is constant. If it is AC, that is varying, that is going to vary sinusoidally with time. Define power. Here, before going to the power, first we need to discuss what is energy. Energy is nothing but what is the capacity to do the work. What is the capacity to do the work? Because if, let us take the example, if there are two persons, one person can do a work within 1 day, one person can do the same work with 2 hours. So that is the capacity of those two persons. That is nothing but the capacity or energy levels of those two persons. And here power is the time rate of expending or absorbing energy measured in watts, where power is equals to dw by dt, rate of energy, and power is equals to power in watts, where energy is in joules, t is time in seconds, or power P is equals to VI. V is voltage in volts and I is current in amperes. So power P is equals to dW by dt. This we can write it as dW by dq into dW by dq into dq by dt. So here dW by dq is nothing but energy per unit charge is nothing but voltage, charge per second is nothing but current. So power is equals to VI. Now describe voltage division. Here voltage division is nothing but when two resistors are connected in series or two any electrical elements are connected in series, and that series connected elements are connected to a voltage source, then the voltage will be divided into those two elements. That is nothing but the voltage division. If two resistors are connected in series, then let us take the voltage division formula. Vs R1 R2, this is I. Here I is equals to Vs by R1 plus R2, where VR1 is equals to current flowing through it, because series connected elements are going to have the same current. VR1 is equals to I into R1, that is Vs into R1 by R1 plus R2, and VR2 is equals to I into R2, which is equals to Vs into R1 by R2 by R1 plus R2. Describe current division. It is the current is going to be divided when the elements are connected in parallel. So the current division is a concept in electrical circuit that deals with the distribution of current among the parallel components. In a parallel circuit, different paths exist for the current to flow, and the current is divided among the branches based on their individual conductances. So current I will be divided into I1 plus I2 when the two elements are connected in parallel. The next one is define open circuit. Here open circuit is nothing but an open circuit refers to an electrical circuit in which there is a break or interruption in the continuity of conducting path. That is, there is a break between the two elements in a circuit or in a conducting path. Then that is called a open circuit, which will prevent the flow of electric current. In other words, an open circuit is incomplete and the electrical current cannot complete its intended path from the source through the components back to the source. Define short circuit. Short circuit is nothing but it is a fault in an electrical circuit which is going to have a low resistance path which is formed between 2 points that are not supposed to be directly connected. This unintended connection creates a pathway with minimal or negligible resistance. The short circuit is going to have minimal resistance or zero resistance. That's why in the short circuit more current will flow, allowing a large amount of current to flow. As a result, short circuit can lead to a rapid and excessive flow of electric current, potentially causing damage to the components. and this will create overheating and posing a fire hazard. When the overheat is happens, automatically a fire hazard which is going to takes place. Define voltage. Voltage is also referred to as electrical potential difference. It is a measure of potential energy per unit charge in an electrical circuit, and it is the force or energy per unit charge that drives the flow of electric current in a conductor. Voltage is typically denoted by the symbol V and is measured in volts. V is equals to just potential energy per unit charge, dW by dQ, that is joules per coulombs or volts are the units for voltage. Define potential energy. In the context of electricity, potential energy is associated with the configuration or arrangement of electric charges within an electric field. Electric potential energy is the energy that a charged object possesses due to its position relative to other charged objects in an electric field. Or we can also say the potential energy as it is the energy of a particular unit charge. It is the energy to bring a unit positive charge from infinity to that particular point in an electric field is called the potential energy. Describe independent sources. The name itself says independent. The sources which are independent of the other parameters in the circuit are called independent sources. And here the independent sources also we are going to have voltage source and current sources. And these sources are not influenced by the current or voltage elsewhere in the circuit, and their values are set independently. The symbol for the independent voltage source is a circle with positive and negative, or with a two lines, one small line and one big line. Big line indicates the positive and small line indicates the negative. This is the Vs. Describe active elements. The active elements, the name itself says the active elements. Active elements in the circuit are the elements which are going to be active in the circuit, which are going to deliver the energy to the other parts of the circuit like resistors, capacitors and inductors. And these active elements are going to play a crucial role in amplifying signals, controlling currents and generating oscillations in the electrical circuits. Describe passive elements. Passive elements in the context of electrical circuits are components that do not supply energy to the circuit but rather respond to the electrical signals or store and dissipate the energy. And these elements cannot amplify signals or generate power on their own. The passive elements are the elements which are going to absorb the energy from the active elements. These are not going to generate any power inside it. The three primary passive elements are resistors, capacitors, and inductors. Describe the linear elements. The linear elements are nothing but its the elements voltage and current characteristic is a linear, that is which is it is a straight line which is passing through the origin. the straight line which is passing through the origin, that is voltage and current. V is proportional to I. In other words, the response or behavior of these elements is proportional to the applied stimulus. The principle of superposition holds for linear elements, which means that the response to a sum of multiple inputs is equal to the sum of the responses to individual inputs. And describe nonlinear elements. Nonlinear elements are the elements which do not flow a linear relationship between the input and output signals. Unlike linear elements, the response of nonlinear elements is not proportional to the applied stimulus. That is not proportional to the voltage. V and I are not proportional. The principle of superposition may not hold. The nonlinear behavior can introduce complexities in circuit analysis, as we cannot write direct mathematical relationships corresponding to these elements. Like examples for nonlinear elements like diode, thyristor, transistor, all these are the nonlinear elements. Define lumped elements. The name itself says lumped element. Lumped is nothing but a small elements. The lumped elements are the elements which are the components in the electrical circuits. That is where we can connect our circuits by using these elements. It is a small circuit which we can place the and this circuit we can separate these elements for our analytical purpose. Lumped elements refer to discrete electronic components in a circuit that are considered to have their properties concentrated at a specific points in space rather than a distributed over the entire circuit. In other words, lumped elements are assumed to have their effects localized at a specific location, and their behavior is described by parameters such as resistance, capacitance, inductance, and voltage, which are associated with specific points in the circuit. Define distributed elements. This is opposite. Distributed elements is opposite to the lumped elements. These are distributed among the certain length of the conductor. That is resistance of a conductor or inductance of a conductor or capacitance of a conductor. This we cannot separate for our practical purpose. Distributed elements in the context of electrical circuits refer to the components or structures where the effects of particular element are not concentrated at a single point but are spread out over a significant portion of the circuit. In distributed systems, the physical dimensions of the components become significant and the behavior of the element is described in terms of fields and distributed parameter rather than the lumped quantities. Next, define frequency. The frequency is a fundamental concept in physics and engineering that refers to the number of cycles or occurrences of a periodic event in a unit of time. It is often used to describe the rate at which the waveform oscillates, such as the vibrations of a sound wave, the oscillations of a magnetic wave, or the repetitive cycles of periodic signal. Frequency is nothing but number of cycles in a particular time, that is equals to frequency is equals to 1 by t in hertz. And these are the some of the basic definitions corresponding to the electrical circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.